Gravity is not a force, and since there's no force pushing down on you, that means you're currently accelerating upwards. If you hold something in your hand, that's not the gravitational force pushing it down, because gravity isn't a force. It's pushing on your hand because you are accelerating it upward. But wait, you may say, there's also the gravitational force pushing down, so the two forces balance to zero, right? No, because gravity is not a force. Gravity is a consequence of moving in a space-time that's been curved by the presence of masses. In this curved space-time around a planet, if there's no force acting on you, you fall towards the planet. That's not an acceleration. But if something gets in your way, like the surface of the planet, then that creates a force, so now you're accelerated. This is why there's no force pushing down on you right now. There's only a force pushing up. The point where people usually go wrong is to conclude that because gravity is indistinguishable from acceleration, that means gravity accelerates you. But that isn't so, because to accelerate something you need a force, and gravity is not a force. The Newtonian picture is the one we learn at school, and it's useful so long as you are on Earth, but strictly speaking it's wrong. Now, of course, physicists are no linguistic saints, and they'll sometimes refer to gravity as a force, even though it isn't. A typical example is when they speak of the four fundamental forces of nature. If they're being careful, they'll refer to it as the gravitational interaction and the four fundamental interactions. But often they don't. I think they really just call it a force because that starts with an F. In a nutshell, why is gravity not a force? Because if you are only exposed to the gravitational interaction, you fall, and that is measurably not an acceleration.